Recording. Did anybody look at the two different reviews and work on any of them? No? That's heartbreaking. Well, now's your chance. Grab your phone or laptop or whatever you do, open up both reviews, look at them and find problems that look way too hard to do so we can work them together. You don't need a Scantron. It's going to be in this room. It's going to be on the days that HBU's website says, which I believe for this class are going to be Wednesday at, anybody know? 2-ish?
It's Wednesday, 10:15 from 12:30 to 2:30.
Oh, gotcha.
And then Thursday, 2:45 to 4:45.
12:30 to 2:45? Or 2:30-ish?
Or December 14th on Wednesday, 12:30 to 1:30.
Oh.
Thursday, December 15th,
No.
2:45 to 3:30.
12:30 to 2:30? And then Thursday is at what time?
2:45 to 3:30.
No. They're 2-hour blocks.
Yeah, they're 2 hours.
Are you looking at the...
Doesn't matter.
This
You have the wrong thing.
Yeah.
Look at the better thing. What? You got this one?
Yeah, this from the website is 4:45.
Oh, okay. So you have the right start times. The end times are just off. I don't know why that's kind of a weird schedule to have the right start times with different end times. That's this class. That's, if you're watching online, the second block of pre-calculus. This is pre-calculus starting at 12 and ending at 2. Those are our time slots. I'm sorry that they're not the same day. I wish they were as well.
Do you know which days can be calculated?
Yeah, it'll be good. We'll go non and then calc, so you have an extra day to garner it if you need to. Cool. Okay. No Scantron needed. It's in this room, whatever the normal room is. Just bring your brain. Probably Monday I'll do a review. Actually, I could do one on Tuesday. No, not on Tuesday. I can't. I have the thing meeting. Well, I could do one late, but probably on Monday. I'll send an email with the review time. Monday review. I'll probably, honestly, and it doesn't have to be like you stay the whole time, but it'll probably be, no promises here, but it'll probably be from like 12 to 5-ish. Maybe 1 to 5 because I might go get lunch or something. But like, I might just do a whole day of Monday of office hours from 12 to 5, starting at lunchtime and ending at 5. And then I have a test on Monday from 5 to 7. So it'll end at 5, like harsh 5 or 4:45 ending. Yeah. So that way you can spend this weekend really practicing these problems. We can spend these hours practicing these problems. If you see all the ones we've already got completed here, which will be posted, which are not that many. Oh, there they are. If you see the ones we've already completed, we can do them again. Happy to do them again. But just so you know as well, there's a video of us doing those ones online posted already. Well, it'll be posted in 75%. So that's just resources for you to go home and study. All right, let's get started. We can do calculator. We can do non-calculator. We can do ones that have already been done. We can do ones that haven't been done. I'm happy to do whatever you want to do to help you succeed as best as possible. So let me know. I'm here. But I'm not just going to go 1 through 100 for you. Like, you got to pick. I'm not picking for you.
Can we do a graph?
A graph? What kind? There's like 3 different kinds. There's like the sine wave graph. There's like the, rational function graph.
Like if there is any specific one.
Of graphing?
Yeah.
Evaluate the piecewise, final zeros, final possible, solve the rational, find the exact, solve the logarithm, find the amplitude. Boom. Wait, no, that's not it. That one? 11. You're talking about 11? Like graphing a sine wave? Or no?
Well, no, because like graphing sine wave.
Which one of those?
Maybe last one.
Okay, let's do it. Boop. This is great. Now we have 2 of the 4 done. You can go home and rewatch to practice. I'm going to do it down at the bottom, so I'll make a note. Done. at bottom. Just so if you're going studying later, you can go check it. All right, let's see what happens. Maybe not. I am working this little computer to the bone. It's like getting super hot, and I can feel the fan blowing. That's all right. Good for you. It's good to do hard things. All right, here we go. Okay, so when you get to something like this, there's those 4 main questions they always ask. Amplitude, phase shift, which is the same as a horizontal shift. Phase means horizontal. I don't know why. What is the other things they could ask? Period. And really, actually, that's it. There's only 3. I lied. Holy crap, this is getting hot. It's kind of burning my hand. I don't think that's good. Oh well. One of those you should get right, and you should be done and be like, oh, I got 2 of the 10 points or whatever right away. Amplitude, you should get right away. There's never been any special thing to do for amplitude, ever. It's always just been, this is what it is. So which one of those 3 numbers is in the amplitude? Absolutely, 1/2. It's right there. Boom, boom, boom. That's the amplitude. Okay? The next easiest one to do, I think, is the... Well, I guess you get kind of period and phase shift at the same time. You have to factor out... You have to factor out something to get a theta by itself. So what do we have to factor out of this thing to get theta by itself? In order to get theta by itself, there's something keeping it from being by itself. It looks like a 1/2. And if you take a 1/2 out of the first term, you get theta. And if you take a 1/2 out of the second term, we got to decide what we get. You gotta know about like fractions and stuff. So the real way to do this is called keep, change, flip. But if you don't like that, you can just kind of reason your way through it by doing like reverse distribution. So you keep, then you change the division to multiplication, and then you flip the fraction that's called 1/2. Well, what's the flip of 1/2? Not 1/2. It's 2/1, right? I almost did 1/2. And then you get 6 pi over 4, which is kind of the same thing as 3 pi over 2. But that's kind of hard to remember or do, so how can you check and make sure you did it right? How do you check and make sure you factored the right thing? Oh no. What's the opposite of factoring? Distribute. Yeah. So if you distribute this theta to this 1/2, do you get theta over 2? And if you distribute it to this, do you get 3 pi over 4? Yeah. So cool. We picked the right thing. So that tells us our phase shift right there, or our horizontal shift. How much is this horizontally shifted? Which way? Because it's opposite, right? Always. So negative 3 pi over 2. Or if you want to write 3 pi over 2 to the left, I mean, that's equally as correct. Okay? And then the period. How do we find our period? There's a formula for it. It is T equals 2 pi over K, which equals 2 pi over 1/2, which equals 4 pi. And then we got to graph it. So I guess the first thing to do to graph it would be to graph these lines at negative 1/2 and 1/2. And then we ask ourselves, what is cosecant like? Cosecant is kind of like the opposite of sine or cosine? Sine? Okay, so let's graph that sine wave then. I want to graph that sine wave. And that sine wave has a period of 4 pi And it starts at negative 3 pi over 2, which is that's a nice even number. That's like, what's it called? 270 degrees, right? 3 pi over 2 is like one of the 4 coordinates. So like that'll be on your graph for you to see. So you start your sine wave there, and where do you finish it at? Probably way over here. Probably at negative 3 pi over 2 plus 4 pi, which is the same thing as negative 3 pi over 2 plus 8 pi over 2. So 5 pi over 2. And then you just kind of extrapolate from there. But wait. We're not graphing the sine wave. Which wave are we graphing? The cosecant? So we take those x-intercepts and we make them vertical asymptotes. And then we graph kind of like the opposite looking things. So we go and hit the same spot, and hit the same spot. And that pink graph is your graph. So it's going to look like this. Looks like. And you usually only have to graph one period, so that would be plenty to graph. That's how you graph cosecant. Secant's the exact same way. You would just start with a cosine instead of a sine and hit the peaks, graph the inverse. This spot is the same on both. Does that make sense that that spot would be the same on both? If the graph is technically flip over a flip, right? Cosecant and secant flipped. That means that the inside, if theta is 1/2, or no, not theta is 1/2. If theta is whatever this number is, then the y value should be a 1/2, which is the amplitude for both. So that kind of means the middle term better be the same for both. That means that this point is wherever the cosecant equals the secant. Or sine. I don't know why I said secant. It'd be worth checking out. Do the sine of all that and the cosecant of all that and see what happens. Alright. What else? What other problems? Or too hard? Or impossible? Or just straight up confusing? One of 10? On which section? This one? Solve the following equations. Oop, and they didn't say for all. They said on a range. So that means we're going to have a limited number of answers. All right. Which one looks the worst? B looks like it has the most stuff. Let's do B. Just because it has the most stuff there. Like the most things to apply. Okay. Cosine 2x. That's a thing. Times sine of x plus sine of x equals 0. Cosine of 2x is a thing. What's that thing? Cosine squared minus sine squared? Right? Cosine squared of x minus sine squared of x. Big old bracket. Sine of x plus sine of x equals 0. What are we going to do next? Can we get all signs? I don't know if it's going to help or not. Let's find out what happens if we get all signs. So how do we turn cosine squared into sine squared? 1 minus cosine squared of x. Oh, that's wrong. I'm so done. 1 minus sine squared of x minus sine squared of x times sine of x plus sine of x. So many signs. I don't know if this is the quickest way to do it, but I'm just seeing if it plays out cool or not. So that ends up with 1 minus 2 sine squared of x plus sine of x. You know what we should probably distribute? Wait, whoa. I missed it. I missed one of them. Yeah. I missed the whole bracket thing. Times sine of x plus sine of x equals 0. Let's do a little distribution. Sine of x minus 2 sine squared of x plus sine of x equals 0. What's in common? There's a sign for everything, right? Yank it out of there. Sine of x. And then what's left over? One minus 2 sine squared plus, we probably should have combined like terms first. Plus 1 equals 0. Because I think there's another thing that gets factored out too. Okay, so that's like sine of x, 2 minus 2 sine squared of x equals 0. Can we factor something else out? I'm gonna factor 2 out, just because it's going to make our lives easier. 2 sine of x brackets 1 minus sine squared of x equals 0. What does 1 sine minus sine squared of x turn into? Cosine squared of x? Well, yeah. Do we need to do that? It just changes one move, right? I don't know. You could do it if you want to. You don't have to. Let's not do it. Let's see what happens if we don't do it. So then what do we do with that once we get there? We say 2 sine of x equals 0 and 1 minus sine squared of x equals 0. So we get sine x equals 0. So we get x equal, whoa, what are we doing here? So what does that mean x if the sine of x is 0? No, not there. There and there. The y value is 0 there and there. So what are those two numbers? 0 and pi? What about 2 pi? But what about 2 pi? Look right there. It looks like it's almost included. That's supposed to be up there. It looks like it's almost included, but it's not. So we don't include it. Okay, so there's two solutions. Now let's hop over here and finish this one. This would be negative sine squared of x equals negative 1. Sine squared of x equals 1. Sine of x equals plus or minus 1. X equals yeah. Pi over 2. 3 pi over 2. There's 4 good answers. So our total final answer would be 0, comma, pi over 2, comma, pi, comma, 3 pi over 2. Yeah.
Would it be wrong if like at the very first step we just factor like sine?
No, that'd probably be way easier, huh? So the very first step, if we would have factored out sine of x and said sine of x, big old brackets, cosine of 2x minus plus 1. Okay, but then so then we got to so there that would give us boom 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 our first two solutions. See this? We would that right there would give us that section right away. So then our only next step is to prove that cosine of 2x is the same dang thing as this down here. So cosine of 2x, that's going to give us cosine squared minus sine squared plus 1. Look at that. Something really cool just happened right there. I think it comes from this block right here. What is 1 minus sine squared of x? So we got cosine squared x plus cosine squared x. So 2 cosine squared x. So if we set 2 cosine squared x equal to 0, you get cosine squared x equals 0. You get cosine of x equals 0. Where is the cosine 0? The same 2 spots. Thank you.
Some is like a way to check.
It's a puzzle. There's actually probably more. There were probably like a billion different random things you could have done to get to the same spot. Like actually. Yeah, if you want to try a different way. And then like honestly right here, we could have converted 1 minus sine squared into what? Cosine squared of x. And what that does is leapfrog us all the way ahead to this right here. It leapfrogged us into that spot of the same thing because it is the same and it should always work. That's kind of cool that if we would have done that green thing right there, it would have leapfrogged us to the green thing way over there, ended up with the same answers. Yo.
If one needed to continue to memorize like those different
Cosine ones?
or identities, I guess.
All identities?
Like how
The cosine squared minus sine squared one?
yeah.
So all identities basically. Which ones do we need to know? Or what are you talking about?
Like where can I go to like
All they're like little bold definitions in the notes that are centered. In the notes, they're the bold centered definitions. I haven't made like a page of just like these are the ones from the notes that are going to be on the test and these are not. That would be kind of dirt. No, I haven't done that. I've kind of verbalized it sometimes, but I haven't made that page because that seems like if somebody else saw me make that page that, like another professor, they would not look kindly on that. Granted, this is recorded and posted, but I can tell you that one's important. Whatever one we just did, this one right here, the cosine of 2x turning into that one is important. And actually, when we did learn that, we learned 3 of them for it. Remember, we learned there were like 3. There was only one for the sine. The sine of 2x. Look sharp. Why?
Had a presentation today in C14.
Nice. The sine of 2x is what? This is an important one? Yeah, 2SC. Always just remember it as 2SC. And then the cosine of 2x is what? Cosine squared minus sine squared. And there were 2 others for it, but I've decided they're not worth memorizing. Just go and plug in 1 minus sine squared for the cosine half or 1 minus cosine squared for the sine half, and you'll get the other 2. Like I've decided that instead of memorizing the other 2, just recognize. Oh, so I guess that means the other one that you'd have to memorize to know how to do that would be sine squared of x plus cosine squared of x equals 1. And then what I've said is just go ahead and plug in, if you want to, 1 minus sine squared of x here or 1 minus cosine squared of x here and work it out with just a little algebra to get the other 2 versions. If you want those other 2 definitions from cosine. Which is kind of what we did right there at the end. We substituted negative sine squared x plus 1 for cosine squared right here. All right. Let's keep going. That was a good problem. It's pretty tough. Anybody got any more? $4B on calc or not? 4B on no calc. No calc 4B. What are you confused about?
So we'll just
You do. You just plug it in. What do you just need me to?
I don't know it. And
Wait, which one of the 3 was the confusing part? Like, so like, take this number. Does it go here, here, or here? Why? Yes, because pi over 2 is less than or equal to pi, so we plug it in here, right? So these go away. Those are gone. Those are infinitely gone now. So now we're going to plug that pi over 2 in and get sine squared of theta is sine squared of pi over 2. Oh, that is actually kind of tough without a calculator. Because we know sine of pi over 2, but do we know sine squared of pi over 2? What? But we don't. But that's the sine, not the sine squared. What's the other thing to square root? There's no other side. This is just a plug and chug, not like an equation. Our question is, what's sine squared of pi over 2? Oh, that means the same thing, doesn't it? Ah, that's it. That's all there is to it. And what is the sine of pi over 2? Also known as 1 squared, which is fine. Yeah. You just evaluate. Yeah. I like that one. That one's kind of fun. What? What do you mean easier way? Yeah, and then square it. Yeah, it's just the important step there is recognizing that this important fact, which is always true. So you could actually rewrite it if you ever wanted to. That sine squared of x is technically sine of x squared. Those are the same thing. That's the step that makes it not super obvious immediately. The reason they don't put it here is because it would be super easy to confuse with sine of x squared. What's up? Oh yeah. If it were doing this, you'd if it were worded like this on the test and just a blank in the bottom and not giving you 3 individual things with an equal sign and a blank next to them. If it were 3 individual things with a blank next to them, just put them in the blanks, right? But if it's on you and it's a big old blank, just write f of pi over 2 equals 1. F of pi equals, we can do it real quick. Plug pi into the middle one, cosine. Negative 1. And f of 2 pi is all the way around. Sine times cosine, 1 times 0 is 0. That's fun. Yeah, so just write it like that on the test, and you can just circle each one. You don't even have to. If you just left it like that, that'd be fine. It doesn't. I don't care about that. Is it what? Cozy? Yeah. That's literally the Outlook thing I was just looking at. It's like, a current thing. They have it there? It's going to run out. Is it for teachers or for everybody?
Well, mainly for teachers and students, but
What? They scheduled it during our classes?
well, it was during FRS, but then
Where's it at? Where's that at?
you know where it's done?
No.
Look,
Oh, the main theater.
the main theater.
Yeah.
Yes. Where
The lobby?
the lobby.
It's in the lobby?
Yeah.
That's so far, though. I'll do it during my break. We have a break at 12:50. I'll do it then. Is it over?
I don't know if it'll last till 12:50. There's still food there.
Did you go get food already? Rat snacks. No, we got a review. I want a review.
We do,
You go get me something.
22.
Yeah. Yeah, I'm sure, unless you want a review. But you're going to do fine on it. Just a little bit of everything. You can tell them it's for me and that we're reviewing for a test. 22, which one?
D.
What?
D.
22D. Oh, you just have to know a formula. There's another formula. You're right. Let's, after this, or during the break today, I'll make a list of the formulas. Shh, don't tell anybody. What's the formula for that one? CC minus SS? Psych! It's actually plus because cosine's flipped. Here, let's write these formulas real quick. This is CC minus SS. This is SC minus CS. And this is... Cool. Look at that. Learn something. Okay, so this would be... Let's enumerate it now. Cosine of A, cosine of B, plus sine of A, sine of B. And go back up there. Oh, they literally gave them to us. We're like done. Except I might want to be careful with that quadrant 2 thing. Let sine of A be 3 over 5 in quadrant 1. So I'm going to draw that triangle real quick. Boom, boom, boom. Sine means 3 over 5. So what's this one? Are you sure it's not negative 4? Because it's quadrant 1, it's positive, right? Positive, positive, positive. Okay? So that let's make this our red triangle. This is red triangle. Red. Green triangle. Quadrant 2. Boom, boom. Cosine means 4 over 5. So what's missing? Wait.
-4.
How is the cosine 4 over 5 in the negative quadrant? That seems very impossible. Either way, this is 3. And definitely positive, right? But let's go ahead and fix this for them. And as we take the test, I will make sure if something like that pops up, I also made these up because I was just going quickly. And I was making up the quadrants. Like, 3, 4, random. So this is just me making up a bad problem. That should have definitely had a negative. It won't have that mistake in the thing. Way to come to class. You get that information. So that should have been a -4 right there, right? Because that is going to change something. What's that going to change? It's not going to change the thing they gave us. No, it really doesn't change anything, actually. But we're not needing the tangent for this type of thing. The only thing that would have changed something is perhaps they gave us 1 in the negative side. If they would have given us a quadrant 3 thing, we would have had to, like, if this would have been quadrant 3 instead of quadrant 2, then the sign would have been negative, and that would make the sign -3/5, which they didn't give us, which is kind of wonky. So let's just go ahead and see. A is red, right? And B is green. So we've got cosine of red, 4 over 5. Cosine of green, -4 over 5. Plus sine of red, 3 over 5. Sine of green, another 3 over 5. So like -16 over 25 plus 9 over 25 is -7 over 25. I like that kind. I like the kind where there's not math to be done, or like a lot of math to be done, but there's reasoning behind it. Like, I need to go to the left. I need to go up. That's going to change this. I'm going to plug in these fractions. Basically, like there were sines and cosines, but you never had to use a calculator. There were sines and cosines, but it was free to do as simple math. That's an interesting type of problem. The same type of thing happens when you have the inverse and the regular. Oh, sweet, we're done. That's why it's not hot anymore. Cool. Hang on. Okay. First half of the video from earlier today is uploaded. So, second half will upload later. After we're done. Here. All right. Oh, like this one. This one has sines and cosines. Let's do one of these just while we're on the brainwave of sines and cosines. This one has sines and cosines, but it doesn't have any math to be done or a calculator portion, right? So watch this. Let's do one of the harder ones. The invert cosine of square root 21 over 7. Draw a triangle. Call something theta. What does cosine mean? Cosine means adjacent over hypotenuse. So that means we've got root 21 over 7. How do we find that other side? 7 squared equals root 21 squared plus, call it b squared. So 49 equals 21 plus b squared. So I'm so bad at math. 28 equals b squared. Right? Is that right? Thank you. So then b equals the root 28. Positive or negative? Wait, we don't know. They should have given us a thing. They should have given us a thing. It's okay that they didn't. We'll just work it like it's positive, knowing full well in our brains. Had they said quadrant 2, no, that would have been impossible. Had they said quadrant 4, we would switch sign to negative. Yep. Okay. What?
I say, wouldn't it be quadrant 3? Oh, that's true. Yeah.
Because cosine is positive, we're stuck on the right side. So it's going to be 1 or 4, and then it's up to them to tell us which one. But that's not even what we're doing. We want the sine of this triangle. We don't have to do any cosining. We just want the sine of this triangle. What's the sine of this triangle? Opposite. So root 28 over 7. That's kind of fun. I love the ones where it's like, oh, there's stuff to be done, but actually not. Ooh, if you want to be fancy, 2 root 7 over 7. Right? Yeah. We could. And that would just change the top, and that would just change the top. And it would say, oh, that's fun. Wait, that's a way better answer. Is to say 2 root 7 over 7 if Q1, and negative 2 root 7 over 7 if Q4. I've never seen it worded like that because usually we tell you. Like every problem that you'll see, they'll tell you, I'm pretty sure. But that's the best way to answer that question if we are being good math people. It's not even to say plus or minus. It's to enumerate the two and say when each one happened. Even though they didn't provide it. That would be the best. Like, I like what you said. Should we just include the plus or minus? No, let's go a step farther. Let's include 2 different answers based on 2 different things. Kind of like how cosine and sine sometimes turns into 2 different answers for the same thing. Like 0 and 0 of sine yields 2 answers. Cool. That's fun. Man, I love math. In the non-calculator? 17A. Ooh, fun. This is just knowing those laws, right? Remind me, that's going on the list. We're going to make a list in 7 minutes. That's going on the list. So remind me, the sines, the logs. We'll just do it together, and we'll say everything we can think of. That'll be fun. I should have done that first hour. So what are the laws to apply here? I would do division first. I would always do division first if you see it. Division is the hardest one, and you don't want to split it up. So log 4 of 3 times 5 minus log 4 of root 3. Now split up the multiplication one. Log 4 of 3 plus log 4 of 5 minus log 4 of root 3. And there's one more thing to be done. There's only one more thing to be done, and it's real sneaky. No, because that would be unexpected. That's where we started. If we were to combine it to one log, that would be where we started. But that's how we got our thing. What? The root? How else can we write that root? How else can we write that root? And now what can we do with that 1/2? It goes up there, right? So technically we've got log 4. Let's go. Yeah, it is. I'm pumped.
See, they ran out of plates, so they gave me the entire salad.
Holy moly. You didn't have to do all that. Oh, is it only salad?
No, there's a stuff inside the bowl.
Oh, what?
And like 4 bricks.
You didn't have to do that. Holy smokes. That's awesome. And cake?
and tiramisu.
Dude. That's awesome. I'll bring some snacks for our final. Maybe I'll make some homemade. I'll make some cookies. Is what I'll do. I'll make a crap ton of cookies. Bring them for the final. That'd be a lot of cookies though. 65 times 2 or 3. 200 cookies. That'd be crazy. 180 cookies. It's a lot of cookies. We'll see. I'll try. All right, what's another problem? I can't believe they just had that to give away.
Yeah, they have more. That's crazy.
So, well, we're about to take a break in 4 minutes. Y'all go get
They
something.
still have more. They still have more.
He's like, I'm about to go. Go if you want to go, go. All right, what else we got? We got to do some more review. You going to get some? Yeah, go, dude. Have fun. Get some good food. Don't look at me. Look at your reviews. Hmm?
20, inverse?
Oh, yeah. Oh, that's the worst kind of inverse. It is because you have to do the split, square, unsquare, or whatever. Okay, fine. Switch x and y, right? So technically this is y equals 2x plus 1 over 3x plus 2. Switch them. X equals 2y plus 1. You got any ideas on what you want to try first? Move the denominator over. Distribute. Get all the y's on the same side. Get all the x's on the same side. Divide by. Wait. No, factor out your y term. And then divide one last time to get y by itself. And you're home free. That is no pre-cal in there. There is just, I guess the steps for that would be, or it's not the steps to do this. It's the steps that we encountered on the way there. Were distributing, combining like terms, factoring out, and then dividing would be the steps that we had encountered. It's not like that's the way you do it. Those are just the steps we encountered on this problem. It's a good one to practice. If you can do that inverse, you can do any inverse. That's the hardest inverse type by far. All right, what else we got? Got one more problem for break. Why didn't you ask me?
I can.
Oh, okay. I was like, what?
Can we do 60?
16B.
Oh, we did?
No, this is a different class. Do you want to do? Oh, actually, that's A. Let's do B. Here we go. That's good. They did A. We'll do B. If you see that bottom in the arrow, go look at the bottom. That means it's solved. When you look, if you're looking at it later, it just means there wasn't enough room there. All right, this one they actually didn't like a lot. The last class, nobody liked this one because I don't actually know why. I don't know why it's not fun, but what do you think? Everybody jump to ln is y. Everybody jump to, I want to do the ln. And you can't just jump right into ln. Why can't you just jump into ln? Could you do that? Hang on, don't write this down. Don't write this down. We don't have a rule for that. We don't have a rule for the minus in the middle. Right? We have a rule for times in the middle and divide in the middle, but we don't have a rule for minus in the middle. That's where we got kind of screwed. Right? Okay. So yeah, no. That's why it's not. That's why we got stuck early. What the heck? Whoops. Okay. So here's what we need to recognize. We need to recognize that if something were different, this problem would be so easy. If something were different, this problem would be like the easiest problem ever. It looks a lot like a problem we solve all the time. Like all the time. It does, doesn't it? Ugly, but somewhere in the middle of it, we can kind of see this thing where it looks like x squared minus 5x plus 6 equals 0. We can see that underneath it, right? You can, or actually, let's not call it x because there's already an x in there. Let's call it a. Okay. What do we need a to be? Because we can see that underpinning this whole problem. And if we can't see it, then we want it to look like that, right? That would be dope. If it looked like that, life would be good. What on earth could a be to make this true? And the easiest way to look at it is the middle term, not the first term. Close. I don't think so. To make those exactly the same, what should a be? And I said, look at the middle term. Right there, right? The middle term is the most helpful. E 2x. Screw it. Now ignore that. Pretend like that wasn't there. Pretend like we didn't find that out yet. Solve this problem. What is the solution to this problem? A minus 2, a plus 3 equals 0. So what does that make a? Whoa. Oh, I see.
Minus 2.
I agree. So what does that make a? And a equals 3? But wait. We didn't solve with a. What was a supposed to be? Oh, so now we've got two different. We got e to the 2x equals 2. And e to the 2x equals 3. How do we solve that? Now we can do our thing. Oh, on both sides? And those cancel, right? So now you got 2x equals ln of 2. Now what? To get x by itself. Divide by 2, and you're done. So over here, you should get ln of 3 divided by 2. Two answers. So x equals those two answers. Cool? Weird, but cool. There's the second one you can practice. And then we already solved it, so you can go look at it. The trick is, what letter can I sub in there to make it work pretty nice and neat? And then the second trick, or the way that you really should always do that, is just look at the middle. The middle is always the easiest. The first one's never the easiest. The first one always is trying to trick you with it. So, like, we good on this one? If I go up to the other one, what number was that? 16? So, like, if we look at this one, what do we think the substitution thing is going to be for the other one?
EX.
Normal EX, right? This one's the harder one to recognize from. This one's the easiest one to recognize from because that's the one you want to be perfect, right? That's the one you want to be exactly the same. Don't look at the middle. Don't look at the left or the right. Look in the middle, and that'll tell you. And usually we call it U sub, but you can use A. I use A sometimes. It's called U sub. You just make U equal to that thing, whatever that thing is. Cool. Okay. Take a 5-minute break. Pause. Sweet. Okay, did anybody have any more?
On the calculator one.
Mm-hmm. Extra credit. Which one?
It was 4.
All right, which one?
D.
What? Oh no. What? What? What was?
That was basically
I'm confused. Oh, I don't like being laughed at.
no, it's not even you.
He's laughing at me.
Oh, good. Good. That's better. It asks us for the domain, right? Let's just do the real problem. Like, let's do the whole problem. But domain's good. So, what are the bad domains? There's 3 of them.
0.
It's not an answer to my question.
Oh, wait.
What are the bad domains?
Oh, that's
0.
Sorry.
No. Even if I did say, then the question you just answered is, what should I set the bottom equal to get my domain bad? Yeah, that's what the question you answered, and I know you were thinking the right thing. The bad domains are any number over 0, root of a negative number, log of 0, log of negative number. Okay, only one of those can happen here. The first one. So what are we going to end up doing? Setting our bottom equal to 4x squared minus 4x minus 8 equals 0. Any ideas algebraically? That's the whole pre-cal step. That's the pre-cal step, is knowing to set the bottom equal to 0. That's pre-cal. This is algebra. This is, which honestly, and I told us this, the main thing we mess up is the algebra, not the pre-cal, but that's okay. All right, what are we doing here? Take out a 4. Left with x squared minus x minus 2. Somebody else? Ideas? Well, do something easy first. Someone else did it last class. Yeah. But yes, you're right. You could do them in either order. It's not going to change. I would just do that first. Because now we're left with... That's so easy. You said x minus 2x plus 1? So x equals... But wait. What did we just find? More explicitly, what did we actually just find? Yeah, what type? There's 2 types. Those are technically VAs, aren't they? So yeah, we were trying to solve this domain problem, but in the process, we found the vertical asymptotes. That's kind of fun. Oh, let's pretend like that's -1. Let's pretend like that's 2. That doesn't tell us our domain. It's just what? Yeah. So what are the numbers it can be? Starts at negative infinity, and how far does it go? No.
Oh, negative.
Hits -1, cuts it out, starts over it, right at -1, but not touching it, to 2, cuts it out, starts over, infinity. If you want to picture that on a number line, this is what that exactly looks like if we draw a number line and line it up perfectly. Here's a number line of x values. Here's the point, -1. Actually, I'm not even drawing that line. I'm just going to leave a circle. Here's the point, 2. Here's all the things it's allowed to be. There's the literal 2 things it's not. There's infinity going that way. There's negative infinity going that way. That's a number line representation of the interval we just drew. But interval is the way we're answering the question. I just want you to see like where the cutouts come from. The cutouts come from those 2 points being bad points. Cool. All right, what else? Does anybody want a cold breadstick? Not a joke. I don't want it. Wow, that's crazy. You want a cold breadstick?
Yeah, so
Wrong side.
oh god. It's broken up.
Why?
They told me that.
You didn't think to tell me that?
I didn't expect
So where?
that.
Okay, so I did grab the right side. I grabbed the correct side.
You were so confident. Finally.
There was no wrong or right side.
That's hilarious.
There you go, man. Get a breadstick.
That was fun.
Yeah, we needed something.
It didn't fall on the ground, but that was so funny. I thought at first I was mistaken for grabbing the wrong side and just being so confident in grabbing the wrong side.
I thought I was gonna hit the board and hit you back. I was like,
That would have been funny.
I don't know, they would have put it like this. Yeah.
Or if like someone was behind you and you hit them with it, they just got smacked by a breadstick. That would have been funny. All right. No. Yes, fine. What are the other things to be solved? Yes, and that is this, right? So that yellow stuff is the HA, which is 1 over 4 because the exponents are the same. Okay. This red thing was the VA. This green thing is the x-intercepts, which it looks like are going to end up being x outside of x minus 2. So it looks like it's going to spit out 0, 0, and 2, 0. Everybody cool with that? And then there's one more thing that we're allowed to do. I'm going to make it pink. The y-intercept, and how do we solve that? Yep, f of 0, basically, right? Where you go, boop, 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 and you get 0 over negative 8. Oh, guess what? I knew it was going to be 0, 0 already. You know how I knew that? You know, there's only one y-intercept. I could have told you that before anything started. There can be multiple x-intercepts. There's only one y-intercept ever. All right, so let's go over down here and do all that stuff then. Here's my intercept. Horizontal asymptote ended up being at 1/4. It's an ugly thing to graph. I should have not made those green. Now I'm confused. Rats. That's okay. These are my vertical asymptotes that are supposed to be red. What? Really?
Yeah.
What? Are you just... Oh, you're saying the first 2 of the sections are super easy to graph?
The x-intercept is 2, 0, right?
Oh, I hadn't grabbed the x-intercept yet. Holy smokes. Wait. No.
That's what I'm saying.
Then I did bad math.
No, what happens is...
Oh.
Yeah.
Boop. Well, because there's an x-intercept of 2, 0, and there's a vertical asymptote at 2, it turns itself into a removable hole. Boop. Which actually made the graph a whole lot easier to do. So where is how do we know what side to graph on? Well, this bottom one looks done. Whoop, hole. And then this top one actually looks done even though we can't see anything. But the not seeing anything is the thing that makes it nice to know. So what does the not seeing anything tell us? On the left side of that graph, we should know where to put the curve. How do we know where the curve goes? I'll give you two options.
It goes up because there's no x-intercepts.
Because there's nothing here, right? Can't ever touch there, so we're staying up here. Boom. Nice. That's not too bad at all. Yo,
Wait, how did you get
the
that?
top left? Because there's no x-intercept. We found all our x-intercepts already, right? So if it were to be here, down here at the bottom right here, if it were to be there, it would go up, and then it'd be like, oh, shoot, how do I get to that blue line? I can't get to that blue line. You see what I'm saying? This blue line is the horizontal asymptote. This has to get there. This has to approach infinity there. It's got no way to get there because it can't cross that line anywhere. So what we know, it has to be on the top. Like, pretend this pink line is good right here. Just pretend that's a good spot. It's going down. As it gets closer to -1, it's going down. Then it's going to go up, 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 up. Eventually, it has to get infinitely close to that blue line. It can't get infinitely close to that blue line because of that dang x-axis there. And why can't it cross that x-axis? Why can't this line ever cross that x-axis? Because we would already have defined the intercept with our formula stuff. We are not graphing stuff to learn new stuff. We are graphing the stuff we already know. So there's no chance to be like, oh, let me make up a new one right there because I had to have it. Nope. We're not graphing things to learn about the thing. We are graphing what we have already learned about it. And that means that there is no x-intercept on this side. That means that this whole bottom of this thing is pretty much layered out because there's no x-intercept. If there was one x-intercept right there, then I would probably have assumed the contrary. I would probably said, oh, yeah, that's probably like that. Might plug in a number to check, but that's an easier assumption. Like, that's kind of what we did on the bottom there. We said, oh, it's got to touch that thing. It's got to look like that then, because if it's at the top, it's not going to hit the asymptote.
And then can you tell because the entire fraction wasn't negative, it was positive?
Yeah, you can definitely tell if you plug the number in. If we plugged in negative, try plugging in negative a billion. Not really, but just in your brain, negative a billion, the biggest negative number I can do. Ooh, actually, that's ugly, but negative a billion. Will get me a positive number on the top, right? Because squared is positive always, and negative is positive. Cool. And negative a billion will get me negative another positive number. Because it'd be 4 billion. That negative 4 billion in the middle. Likewise, if we plug in something super close to -1, like negative 0.999, or I know that's on the other side, negative 1.01, we could see what happens. By plugging in negative 1.01, we could see what happens to the sign flips. It's actually easier to do that step, the checking step, if you do a fully factored form, which would be x times x minus 2 over 4 outside of x minus 2, x plus 1. It's actually a whole lot easier to plug stuff in. So like I said with the negative a billion, like if we plug in, let's try negative 1.1. Negative 1.1. Negative 1.1 minus 2, that's a negative number. 4. Negative 1.1 minus 2, that's a negative number. Negative 1.1 plus 1, that's also a negative. So positive on the top, positive on the bottom, better be positive up here. Worked out. Yo.
So for that graph, like, why is that like open?
That was something we really glossed over. Remembering, I don't think it's going to show up, but it's because you can cancel this out. We never really saw any of those on test or whatever, but when those two cancel out, what it's saying is it's the normal old graph of x. So basically, if those two things were to cancel out, it would be x over 4 x plus 1, right? That's the thing we're graphing. That's the thing we're graphing. And when we get to that 2, we're just going to put a little hole there.
So it's not just the
No. Oh, sorry. That hole's not on the x-axis. That hole's on the line. No. It doesn't even matter. It doesn't even matter what that is.
We thought it was an x-intercept at first, but
Because it's also an asymptote. It looks kind of like that.
there must have been an animation.
But I don't think there's a graph on our test. I could be wrong, but I don't think there's a graph like that on our test. We just did extra work. We were only looking for the domain. Like, our test is not getting into the weeds so much as we did during the year. Our test is more general topics, and that's kind of weedy. What's up?
So with the whole, we have to like erase the asymptote.
Yeah. It's basically like, oh, our asymptote got pulled away by our x-axis, and it deleted it. But like I said, I don't think that's going to be on there. This test is like, we made a whole lot of extra work for ourselves on a problem that was just domain. If we look at the graph one, I know there is one graph one. I saw it the other day. Look at this. This is the one that sketch a graph. What are all those? Yeah, they're all parabolas. That's a sketch of the graph, not what we just did. This is like the hardest graph you'll have to sketch. So don't like freak out and get studying that thing and not that you forget how to graph a normal style parabola. Now, some of these have extra little distributed FOIL before you can graph it. That's okay. But fine. Yeah, which one? Just the first one? Okay. Well, this is kind of nice because it's in HK mode, but I want to go ahead and pretend like it's not in HK mode, so we can see it happen both ways, because some people might forget on the test. So if you FOIL this, you'll probably get 3 minus x squared minus 4x plus 4, right? Which is negative x squared plus 4x minus 1. Okay. Happy or sad parabola? Sad parabola. Where's the y-intercept? Bless you. 0, negative 1. Where's the x-intercepts? We don't. This is not an easy solve, is it? No, you're not. Negative 4 plus or minus the square root of 4 squared minus 4 times negative 1 times negative 1 all over 2 times negative 1. Negative 4 plus or minus the square root of 16 minus plus minus 4 all over negative 2. Negative 4 plus or minus the square root of 12 over negative 2. Negative 4 plus or minus the square root times 2 of 3 all over negative 2. Negative 2 plus or minus root 3. There's your 2 xi's. Well, the negative just goes into plus or minus. Is that what you're talking about? It flips the sign, but you don't. You're going to get both of them no matter which way you go and do it. So, there's your xi's. So let's graph this thing now that we. Oh wait, we need 1 or 2 more things to graph it. The vertex, and what's the formula for the vertex? Negative b over 2a, which is? Which is just 2? That's not a vertex, that's a number. That's the x coordinate of the vertex. So what do you do with that? Plug it in. So you get negative 2 squared plus 4 times 2 minus 1. Negative 4 plus 8 minus 1. Y'all, what should we have noticed already? Look at those 2 numbers. And then look over at what we started with. It's already in vertex form, but I wanted to work it out so we could see it, just in case someone forgets, or in case they give you this one. That, right? If they give you that one, we had to do what we just did. So now I'm going to hop over. I'm going to say, let's graph everything we know. We know the y-intercept of 0, negative 1. We know the x-intercepts of 2 plus root 3 and 2 minus root 3. We know it's, whoa. It's supposed to be a sad parabola.
Oh, is it because
One hundred. What? Oh, is that not where 2 minus root 3 is? That's not where 2 minus root 3 is. What is root 3? It's like 1 point something? That was a terrible drawing of mine. I was so confused. It's like right there, right? 2 minus root 3. Oh, I was so... Is that okay to be a sad parabola? Yeah, actually, that's not okay to be happy now. That's not a happy parabola. I was so confused for a second. But we haven't done the vertex yet. Where's the vertex at? Oh, look at that. Right in the middle of those two? Exactly in the middle by root 3?
It has to be in the middle.
Because it's the vertex. And those are x-intercepts. And it has to be in the middle because, look, there's a 2 plus root 3 minus root 3. That's perfect. It worked out perfect. And how high are we going? Up to 3. This is 2. There's our vertex. Heck, you know what? There's one more point that I actually know. The mirror one. Yeah, just for fun. The mirror of this point, because this point is 0, negative 1. How far away is that from that line? 2. So how far over are we going to go? Another 2 and get our point 4, negative 1, just for fun. That wouldn't be like you have to do on the test, but it's just to make a perfect little graph. Yum. And that's about every point you could possibly know. Well, I mean, I guess you could go plot random points too. If you get super stuck, go do 1, 2, 3, 4, 5 and just plug them all in. But that's pretty fun. Yeah, if you would have ended up getting stuck on this test and it gave you the graph and you just plugged in the normal thing we always check, which would have been -2, -1, 0, 1, 2, you would have ended up getting this point on right, because that's on there. This 4 you could have ended up getting. This 2 point right. So you would have gotten almost 3 of those. Like, you would have been in a decent spot if you would have just done that. You wouldn't have gotten the x-intercepts, but I didn't necessarily ask for the x-intercepts. So, all right, sorry. Long problem for that one, but that was fun. What else we got going on? What? I didn't see it, but okay. How? From what? Let me see. I'll look. Let me look. I don't remember it. Okay. The 7th?
The 7th.
That one? Oh, I saw that. There's nothing. We didn't have anything before the 7th.
Okay.
What?
We had something recently. I need to make up for this.
Oh, okay. Sorry, yeah, I saw it and I was like, oh, cool, we don't have anything before the 7th. I didn't know you were asking to make it up or whatever. Whenever you can make it up, I don't mind. As long as you make it up before next Thursday, I guess.
Okay.
I really have no preference.
Okay. Is there anything I have to do? Do I have to come in? and-
No, just any time you can that works for you that is on your schedule. I just don't know your schedule. I don't know 200 people's schedule. I only know mine. So,
I don't know either. But right now I got 100 people.
okay.
And I'm 67
That's fine.
over 20.
Yeah, no, I don't mind. But yeah, I didn't know that was
On my schedule.
okay.
2. I was looking at 2.
This one right here? No, you know how to do 2.
Well, can you like explain what the text is asking for? Like,
I think it's literally, if this is what I think it is.
Is it asking for the box?
No, I think it's literally just sine of A. Here's A. So the sine of A is 40 over 50? 4 over 5? Opposite over hypotenuse.
So are we finding sine for each letter and cosine?
Yeah, it says find sine, cosine, and tangent for A, B, and C for all of them.
Oh, okay.
But it's just a fraction for each of them. They're already done.
Yeah.
Yeah.
I
You just didn't know it was harder than that?
Yeah.
No, I think that's it. This is for determine the sine for A, B, and C for each of the following, and they're all given. So that means that one's probably going to be all given and ask you for one of those 9 things. Or 3 things. Because it's only going to be one triangle this time. So that's what that probably means. I don't know which of the 3 would be.
That's kind of worded very strange.
Well, that's just to give you practice doing it 9 times. The test wording won't be that. The test wording will be it'll have one triangle, and it'll say, what's the cosine of A? Like, it'll be one of those 9 questions. I just didn't know how to do that over and over and over. What's the cosine of A? Adjacent over hypotenuse. But I said, here's a way to practice that same concept 9 different times in 9 different ways. Determine the sine, cosine, and tangent for A, B, and C in all of the following triangles.
Okay.
It's actually not 9. That's
What about the
27 things.
Yeah,
What?
what about B?
B still has a... Oh.
Yeah. B is the one that's like.
It's just sine and tangent.
Never mind. B's gone. A and C. Good catch.
I was like wondering the whole time. I was like, how can you?
Well, wait. Watch this. No, watch. Opposite over hypotenuse. Watch this. The sine of B equals opposite over hypotenuse. So the sine of 90 better be 1. Is that true? I rescind my thing. Find them.
I've never seen it like that.
But it's true.
That makes sense.
That was cool. That was a good question because I got hiccuped, and then when we did it, I was like, "Oh no, it works." Does it work for all of them? What about the adjacent? No, the cosine of B doesn't work because there's no adjacent. Adjacent over hypotenuse, that doesn't even make sense.
Well,
Oh, yeah.
it's -1, right? Wait, 90. Cosine, what's cosine 90?
Adjacent over hypotenuse.
0. Cosine 90 is 0.
But there's no adjacent side. So I guess you're right. Cosine doesn't work. We just got lucky that I picked sine first. Because there's no adjacent. It would be the cosine of B can't be the same thing as the cosine of C, and it looks like it would be. So no cosine.
So if it doesn't
That's why I'm
make
saying it
0
doesn't.
over something, which is 0.
Because there's 2 of them. Because there's 2 adjacent sides. It means it's not a function. But that doesn't make it 0. That would make it undefined. So that's not good reasoning. I don't know. I have to think about it. Don't worry about it. You know what the problem's asking. Okay, I'm back on board.
It doesn't exist, so it's 0.
I'm back on board. Next B. I don't know. Because it's not. I promise that's not the thing they'll be asking on the test. You can see the problem they'll be asking you. Okay, let's keep going. Let's not get lost in the weeds. We have pans of lasagna left over. It was good.
Yeah, they have like cake left over.
That cake was pretty tasty, not gonna lie.
Like if they had a pan of that,
A pan of cake. All right, we can do one more problem, maybe 2. While y'all look, I'm going to see if I can make sure I save this so I know that it gets. Save as. Yes, calculator. Completed. Save this one as no calculator. Save as no calculator. Completed. I'll go here. I don't even know what room is that right there. It's nothing. Unless it's upstairs. Okay, final exam review. Enter. Final review. No. C. Completed. Final review. Yes. C. Completed. Anybody find one to do? One last one before we never see each other again?
Question about number 9. Is it actually, I can't speak. Are we trying to find if it makes a triangle, or what are our solutions technically
For number 9?
on the calculator? Yeah.
Solve. Oh, no, that's dope. So that's on the calculator or no calculator?
Calculator.
Oh, okay. Number 9 on the no calculator is pretty cool too. Oh, shoot. You should definitely. I'll do this in a second, but you should definitely watch the video. Okay, so what is your question, and then I'll answer it, and then we can do one.
I was saying it says find the solutions, but are we proving is it a triangle period?
Yeah. Well, some of them are going to not be triangles.
Yeah.
So, like a second ago, this is the one I did with the other class. Our angle was 42, and that was a reverse sine, arc sine, inverse sine. So the other invert sine of that was this 137, right?
Yeah.
But what happened when we plugged in 137 up here to be our second triangle? We already had 120. 120 and 137 did not work, and so we just scratched out and didn't even keep going down that rabbit hole. But we did keep going down this 42 rabbit hole and then we subtracted 120 and 42 from 180 to get our last thing. And it was actually pretty easy from there. The hard step was getting two of the same thing and figuring out which one to use. The easy step was getting the third.
So C would be your answer you're giving, or you're trying to find?
No, it says solve the triangle, determine all possible solutions. So you're trying to get all three sides and all three angles. And they've given you two sides and one angle. So you use the law of cosines for the next angle. 180 minus numbers for the next angle, and then you're just one side short, so you just got to go hunt down that side.
So the answer is just complete a triangle.
Yes. But every once in a while, there's two that work, and that's where it gets a little slippery. When there's two that work, you got to be really careful. Actually, we can do that real quick. Let me post this because I was so darn close to it, and then we'll do one of those and call it a day. Final review, no, attach. You see the completed one? Anybody see it up there? Final review, no calculator. What? Where is it? Refresh. I just don't want to not have people. Oh, I saved it in test 3. That was silly of me, but it's too late to go back now. There it is. Final exam review. Yes, calculator completed? Or no calculators first?
Calculator.
Good catch. You're right. Boop. Boop. Oh, you were wrong. It's okay. Yes, calculator. No calculator. Sorry. Okay, now you can see everything we're doing, which is really good. Okay, let's do one of these. 6 minutes. Pick one, not whichever one we just did, which looks like we did A. So which one do you want to do? D sounds good. I'm going to drag it down to the bottom. I actually really enjoy these problems. This triangle one. I don't know why. It's just kind of cool to see. What? No. What? You know how you copy stuff? This is just not working good. Story of my life. The minimize button and the copy button are on top of each other. Haha. Y'all. Sometimes technology is just tough like that. All right, there we go. All right, so we're going to draw a triangle. Boop, 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 boop. I'm going to go green for A, which is 40 degrees, yeah? Call A the opposite side. Just always call them the opposite letters. It's the best protocol. We got B. We got lowercase b. Do we know either of those?
A is fine.
Oh, shoot. We know that too? Dang, we're flying. So the only thing we're missing is C, the angle, C, the side, and B, the angle. Which one do we want to go for first? B, the angle, right? Because look at this. Look at this green pair that we've got. Well, you can't. There we go. I don't know. Should have been a long day for this pen, I suppose. So we've got sine of 40 over 5 better be equal to what? That's dope. Which means sine b equals 9 sine 40 over 5. How do we get rid of sine b? Arc sine it, right? Arc sine it. And what you do to one side, you got to do the other. So b better be the arc sine of 9 sine 40 over 5. I need someone calculator, and we got to go quick. We're running out of time. 3 minutes left. Sine 40 is not a pretty number, so I don't know it. I'd have to calculate it up. Everybody just watching the World Cup? That's happening?
Huh?
It's the worst time slot for a class. He said the same thing. He said, anybody get it? Fine, I'll do it too. Oh, come on now. Sine 40, close it, times it by 9, divided by 5, 1.15, arc sine 1.15. Undefined?
Yeah, B. Yeah.
What? Actually?
So does that mean it's not prime?
No, I got undefined, and I think we did it. Yeah. You know what that means? This is great, and it's super possible. I haven't checked the one on the final. I don't know what's going to happen, but go look at the original. Guess what that means? Boom, that's your answer. And that's one of the answers on the final. Like it says, determine whether it's 0, 1, or 2. And I don't know which of the three it's going to be. I did a one solution earlier with the first class, but as you work through all those, there's each of those types. 2 solutions are the worst of the 3. I'll give you that because you have to build 2 different triangles. But that's cool that we got to do a 0. I've never done that yet. I don't think I've ever done that in this whole class, like all year. Cool. That was fun. Okay, so I did D and I did A. Worth trying to do all the other ones. I think that's a really important type of problem. That kind of just blends in literally everything we did for the whole class. I'll end the video on this so that if you're watching at home.
So you put like no solution.
Absolutely. There are no triangles or no triangles. This makes no triangles or no solution, no triangle or whatever. This is a pretty important thing for you to know. This list. And it continues on the next page. We made a whole 2 pages of a list of things to know. I think that's pretty much most of the things I know that you need to memorize or have remembered. I don't know. I'll send an email for Monday about what time I'll end up here. And I'll just do it in this room, and I'll be here for 4 hours. If you have questions or lots of questions or just 1 or 2, you can swing by and ask. My guess is 1 to 5, maybe 12 to 5, depending on lunch or whatever. But that would be my guess would be a pretty sweet 4-hour block to study. And that's like 2 days before your test, which is sweet.
Yeah,
Yeah. So it's not pointless. Like Tuesday night, kind of dumb, pointless. But Monday afternoon is not a bad idea. So, all right.
I won't be available either.